Hello there, welcome to my channel on chemistry lessons. This channel provides full lesson content and full lesson videos on all chemistry topics for AQA, A-level chemistry and BTEC applied science. I will be uploading regular content. Initially it'll be full lesson content, and as we get closer to the exams I'm going to be looking at focusing on key concepts and exam technique. So please subscribe so you don't miss out on future content, and also use the comments features to let me know what you think of the videos and any future videos you think would be useful. Good luck. So this video is an AQA A-level chemistry video. It's a first year topic this. It's topic 3.1.7, which is redox, and it's the first of two lessons, and this lesson is going to focus on assigning oxidation states and what oxidation states actually are. So always start with the specification, and it looks fairly short. As you can see, there's only 3 bullet points there. Don't underestimate it though, because it's a skill rather than a vast amount of content. It's a skill of being able to assign oxidation states, and it is something that you do need throughout chemistry. You are going to need it in several second year topics as well, and it's an absolute guarantee in any year 2 test that you'll be expected to assign oxidation states. So that's where we're going to start. So from GCSE, you bring some of this language with you already. You bring with you oxidation and reduction maybe. So just to remind us of something that a lot of students bring with them is to remember this acronym Oilrig, which is oxidation is loss and reduction is gain. And this is in terms of electrons. And that was where it stopped at GCSE. If you could identify something as losing electrons, that it's been oxidized or it's oxidation, and something that has been reduced was a gaining electrons. Okay, so reduction, reduced, gain of electrons, oxidation, oxidized is loss of electrons. Now, you won't have used these two terms, but they're fairly straightforward. So an oxidizing agent, it's something that oxidizes something else. So an oxidizing agent is something that will take electrons. So if you take electrons from something, you are oxidizing it. You are an oxidizing agent. So you could visualize this as an oxidizing agent is being reduced. It is taking electrons. And the complete reverse of that, a reducing agent is something that will give electrons to something. You are allowing something else to be reduced. If you reduce something, you give it electrons. So a reducing agent is something that donates electrons. Okay, so make sure you have those terms very clear. Oxidizing agent and oxidized are not the same thing. They're actually quite the opposite. So make sure you've got those 4 key terms very clear. So, what is an oxidation state or an oxidation number? It is all about electrons, okay? We focused on oxidation being loss, reduction being gain, oxidizing agent, reducing agent. It's all about electrons. So the oxidation state or the oxidation number, that is showing you how many electrons something has gained or lost. That's the whole point in the oxidation number. So something with an oxidation number of 0, that means it hasn't gained or lost any electrons, okay? Something with an oxidation state of +2, that would be telling you that it has lost 2 electrons. So it's very much the same or linked to charge. So if you're an oxidation state +2, it means that you have lost 2 electrons from your ground state or your 0 state, from 0 oxidation state. And likewise, if you had an oxidation state of -3, that would be that you have gained 3 electrons. Okay? So if in a reaction, let's just say that you go from +2 to +4, you are showing that you've gone from an oxidation state of +2 to an oxidation state of +4. That means you have lost 2 electrons and you have been oxidized, or you're a reducing agent. Okay? So now what we need to do is look at how we actually assign oxidation numbers. Now it can feel overwhelming to start with because there's quite a few rules that we have to follow, but once we understand the rules it becomes straightforward. Kind of like any set of rules. The first time you come across a set of rules, first time you play a game at home, or the first time you play Monopoly, the first time you play a board game, you don't really know what's going on, or a card game, you have no idea. But once you've played the game a few times, you kind of pick it up. And it's kind of like this. When I'm going to tell you the rules, you're going to kind of think, well, okay, I'm picking those up. Just like you do with a card game. If someone tries to explain it to you, it's always far easier just to play a couple of games. So I'm going to go through the rules. And then the best thing is that we're going to look at some worked examples. So elements always have the oxidation state 0, because if it's an element, it hasn't gained or lost any electrons. That makes sense. Okay, so an oxidation state 0 means it hasn't gained or lost any electrons. The maximum oxidation state that something can have is its group number. That also makes sense. You're not going to lose more electrons than you have in your outer shell. Okay, so the maximum oxidation state of something is its group number. So something in group 2, the maximum oxidation state or maximum oxidation number is +2. Okay, likewise, something in group 7, the maximum oxidation state it could have is +7. Unlikely, but it's possible. Okay, so it could lose all 7. And the complete reverse of that, the minimum oxidation state is the group number -8. Now, what that kind of makes sense. So something in group 7, the minimum oxidation state would be -1. It can only gain 1 electron. So this is that octet rule of electrons. And if you're in group 2, the maximum number of electrons you can gain is 6. Therefore, the minimum oxidation state is -6. Just remember, a minus oxidation state means you've gained electrons, and a positive oxidation state means you've lost electrons. Okay, so that does make sense. Something in group 5, 5 minus 8 is -3, and that makes sense. Something that has 5 electrons can gain up to 3, which would be a -3 oxidation state. Now, if we are looking at an ion, the oxidation state is the charge of the ion. So for example, if you looked at magnesium 2+, or something like oxide or 2-, or maybe chloride, the oxidation state is the charge. So the oxidation state of magnesium here is +2, oxidation state of oxygen here is -2, oxidation state of chlorine here is -1. It's just the charge, okay? Now, if it's a compound, let's just say we've got a compound like water, H2O. Now, the sum of the oxidation states here must add up to 0, because water has no overall charge. So whatever the oxidation state of hydrogen is, and whatever the oxidation state of oxygen is, if we add them all together, the sum must be 0. Okay, and more of that in a minute when we look at some examples. Now, if you've got an ion, so let me just think of an ion, I'll make some space over here. So if we were to think of a common ion that we've seen before, something like sulfate, the sum of the oxidation states in this case must add up to -2, because the overall charge here is -2. So whatever the oxidation states of 1 sulfur and 4 oxygens are, the sum of them must be -2. Again, that might seem a little bit hazy at the moment, and when we do some examples, it will start to make sense. Moving on with the rules. So, oxygen will always have an oxidation state of -2 in compounds, except when it's in peroxide. So there is an exception there. So oxygen as an element is obviously 0. We've seen that elements are 0, but if oxygen is combined in a compound, then it will have the oxidation state of -2 unless that compound is a peroxide. So there is an exception there. There is another exception, OF2, where oxygen will in fact also be +2 in that case. So there are a couple of exceptions. The main one that you'll come across in your exams though is going to be peroxides, such as hydrogen peroxide. So in hydrogen peroxide, oxygen is in fact -1. There's 2 oxygens there. Both of them are -1, which means they both gained an electron. Second rule, hydrogen in compounds is always +1. So obviously again, as an element it's 0, but when it's in a compound it's always going to be +1, except in hydrides. Usually you'll come across metal hydrides. So in metal hydrides, hydrogen will be in fact -1. It does feel confusing and overwhelming at times, but trust me, these rules do get quite easy to follow. No exceptions there. Group 1 metals in compounds will always be +1. Group 2 metals in compounds will always be +2. No exceptions there in group 1 and group 2. Now the D block elements, they have variable oxidation states, so they can vary, and you'll have already seen that in some compounds earlier on where you've got iron 2 or iron 3, and we often see that given in Roman numerals, and that Roman numerals is the charge on the metal, which is the oxidation state of the metal. And finally then, if you've got two elements that are combined, this is the rule that the one that's the most electronegative will be the one that takes the electrons. That should make sense. Electronegativity being the ability the atom has to pull electrons. So the more electronegative is the one that will gain the electrons and it will get a negative oxidation state. The other element will give up its electrons and become positive. So the best thing for us to do really then is to consider all those rules, and I'll try and talk slowly and clearly through each of these examples. So Na2SO4, right, it's a compound. It has no overall charge, it's not an ion. So the sum of all these oxidation states must add up to 0. Now, I'm going to draw it out and you'll see what I'm going to do underneath. I know that sodium is +1 because it's a group 1 metal. Group 1 metals are always +1. Oxygen is always -2 except in peroxides or when it's with fluorine. And here it's not with fluorine and it's not a peroxide. So there's 4 oxygens, they are all -2, so they add up to -8. The sodium adds up to +2, and the overall charge must be 0. Therefore, the oxidation state of sulfur must be +6. So we've assigned oxidation states here. So the oxidation states here, sodium is +1, sulfur is +6, and oxygen is -2. Moving on to the next one, NH4+. So I'm going to take my time and set them all out because they do follow follow the rules. We like to follow the rules. So the next one I'm going to look at will be NH4+. Now this is an ion, so the overall charge is +1, so the sum must add up to +1. Hydrogen is always +1 except in peroxides. We've got 4 of them, so that's +4. So each of the hydrogens is +1. Got 4 +1s there, so that's +4. That means that the nitrogen must be -3 because the sum has to be +1. So -3 + 4 is equal +1. So nitrogen -3, hydrogen is +1. Don't say that hydrogen's +4. Sometimes I see students make that mistake. They'll tell me that hydrogen's +4. It's not. It's +1, but there are 4 of them. Next, KMnO4. Well, K is a group 1 metal, that's +1. Oxygen, we know is -2, except peroxides. This isn't a peroxide, so it's -2. There's 4 of them, so that's -8. That's +1. The overall charge is 0, it's neutral, so the sum must add up to 0. So +1 -8 is -7, so Mn must be +7. So the oxidation state of Mn here is +7. So potassium is +1, Mn is +7, and oxygen is -2. Obviously, I can do these fairly quickly. I'm taking my time here, but it's all about knowing the rules and assigning them. As I've said, it's like playing a game. The first time you play the game is very difficult because you don't know the rules. Rules I'm applying here. Oxygen is always -2, except in peroxide. This isn't peroxide. And the overall charge is -1. So I've got something -8 is -1. So chlorine here is +7. So chlorine is in fact +7 oxidation state. It's lost all 7 electrons. So Cl is +7. Oxygen -2. And that's because you would expect chlorine to gain an electron and become chloride. However, when it's with oxygen, because oxygen is more electronegative, it's going to lose. It's going to be forced to give up those electrons to oxygen. So it's lost all 7 of them. Next, running out of space here, Na2S2O7. Well, the overall charge is 0. Sodium is +1. Oxygen's -2. There's 7 of them. So there's 14. So it's +2 minus 14 plus X is equal to 0 because the overall charge must be 0. Therefore, X here is 12, but be careful, there's 2 sulfurs, so it must be +6 and +6. So that it isn't +12, it's +6 because there's 2 of them. So here my oxidation state, sodium is +1, sulfur is +6, oxygen -2. Right, Fe3O4. If you think you've got it now, you could pause the video and try and do the rest yourself and then unpause me. Just say, shut up, Rob, and then have a go yourself. Or we can just keep going. Let's have a look. Fe3O4, well, -2, -2, -2, -2. So oxygen's -2. And the sum has to be 0. So this adds up to 2, 4, 6, 8. Now, this is awkward, this one, because this must add up to +8. So what's happening here? Because 8 divided by 3 doesn't seem to fit too well. So we've possibly got different oxidation states here. So this is a difficult one. So perhaps we've got +3, +3, +2. That would work. So that's a difficult one, that, okay? Now, that comes with experience knowing that iron has 2 common oxidation states. And they wouldn't do this to you in first year, to be fair. This would be more of a second year type question, okay? Because in second year, you will become familiar with transition metals and iron having 2 oxidation states of +2 and +3. Although, if I wanted to be harsh, I also know that at GCSE, you do cover that in transition metals. So I think we've got 2 oxidation states of the iron here. We've got 2 of them at +3 and 1 of them at +2. Right, next. I need to get a better rubber, don't I? Next, Mg. Oh, this is good. Brackets and all sorts going on here. Gonna have to be careful. Mg. NO3 2. Well, magnesium's group 2, so it's always +2, so that was a bit of an anticlimax. So that's +2. Now we've got 6 oxygens. Why have I put 6? Because I'm saying 6. We've got 6 oxygens, all are -2, so we know that they will add up to -12. So we've got +2, and then we've got 2x because we've got 2 nitrogens. So I might put 2x here, +2x -12. And it's no charge, so it's equal to 0. And then we're going to say that 2x is equal to 10, so x is equal to +5. So here, magnesium is +2, nitrogen is +5, oxygen is -2. So important that we know these rules. If you don't know the rules, you can't do this. It becomes impossible. You can't just use group numbers. Right, NH4VO3. Well, this is difficult, this one. This is the hardest of the lot because to do this one, we need to recognize that it's ammonium. So we can kind of see this as 2 separate things, really, would be the easiest way to do it. So we should recognize that this is ammonium, which is NH4+, and therefore the VO3 is minus, okay? Because if you didn't recognize that, you're going to struggle doing the N and the V separately or at the same time, because you're far easier to split them up here. Because hydrogen will always be +1, oxygen is going to be -2. So this V becomes +5, so I'm doing it in 2 halves here. So V becomes +5, and the N over here, I've got 4 of these, so the N must be -3. So N is -3. H is +1, V is +5, and O is -2. So it's been able to recognize those common ions as well for this one. So for example, we've seen hydroxide. This was way back in week 1 of first year. Hydroxide, ammonium, you've got carbonate, CO3 2-, you've got nitrate, NO3-. Okay, so just remembering those 7 common ions. It's your turn now then. So you're going to pause the video and try and do these 8. When you think you've done them, unpause the video, okay? Right, I'm not going to do all the scribbling and working out, but I'll talk you through them. So oxygen is always -2, hydrogen is +1, and therefore the nitrogen turns out to be +5. So nitrogen is +5, oxygen -2, hydrogen +1. Next one, oxygen is -2, and the nitrogen is +4. And the next one, hydrogen +1, nitrogen -3. So you can see in the first 3 questions, nitrogen's all over the place. Depends what it's bonded to and what it's doing. So in nitric acid, nitrogen is +5. In NO2, it's +4. And in ammonia NH3, it's -3. Okay, let's see what's happening in number 4. Magnesium is +2. And nitrogen is going to be -3 for number 4. We've got magnesium's group 2, always +2. We've got 3 times 2 is 6. So then each nitrogen needs to be -3. Right, now we've got some ions going on here. So the oxygen again is always going to be -2. And the sulfur in this case then works out at +4. Moving on, again, oxygen is -2. And the sulfur in this case is now +2. BaNiO3, well, Ba is in group 2, so it's always +2. Oxygen's going to be -2 because it's always -2, except in peroxides. And now we're going to work out what's happening with the nickel. So we've got +2 -6 plus X is equal to 0. So therefore X is +4. So nickel in this case is +4. And finally, the last one, got a charge of -1 here. So hydrogen is +1. Oxygens are all -2. And that's going to be -2, -7, +6. So phosphorus in this case must be +6. Right, well that's assigning oxidation states and assigning oxidation numbers. It is a skill that you're going to have to pick up, okay? So again, hopefully this was useful. Look out for video 2 where we're going to look at half equations and combining half equations, and also look out for other videos. Enjoy yourselves. Good luck.